Enormously vast and literally without an atmosphere, Jupiter is one of the strangest and most terrifying planets in our solar system. It's perhaps the last name on the list when searching for habitable planets. But all the same, scientists are not giving up on it. So why would we? Pack your bags, fasten your seatbelt, and join us as we travel 150 million kilometres from where you're seated to explore this colossal hot gas called Jupiter. The journey begins now. Mistaken for a lost star by early scientists, Jupiter was left undiscovered or misunderstood until Italian cosmic astrophysicist Galileo Galilei did the honours in the year 1610. Since then, scientists have sent out 9 spacecraft on the wicked and seamless endless journey to Jupiter to help us study its features and prospects of life. Sadly, a handful of them were destroyed by the very planet they were supposed to study. However, some others were able to weather the storm and stay afloat, sending tons and gigabytes of data and history back to Earth. With all due respect to Galileo, the subsequent missions to Jupiter after his discovery utilised more sophisticated equipment than his refracting telescope from the early 1600s. And this allowed us to dissect the Colossus gas giant, picking out all the necessary information about it bit by bit, starting from its size. It's no secret that Jupiter is the most gigantic in our solar system. Over time it has been described with several huge adjectives, but just how big is this planet? The official fact sheet confirms that Jupiter is about 2.5 times bigger than all of the other planets in the solar system combined. That's about 318 times heavier than the mass of Earth. Jupiter's radius measures 43,441 miles, approximately 11 times wider than our planet. For perspective, if the Earth was the size of a nickel, then Jupiter would be the same size as a real-life basketball. But here's the funny twist of Jupiter's enormous size. Jupiter is sometimes ridiculed by petty cosmic critics for being a failed star. But who would blame them though? Well, this gas giant has enough supply of hydrogen, which is one of the requirements that a star must have. It doesn't have enough mass to fuse hydrogen to helium in order to become a real star. So, how much weight does Jupiter need to add for it to become a star? Spoiler alert, the required figure is astronomical, but we'll say it anyway. Jupiter's mass must increase by 13 times what it currently is for it to become a brown dwarf. To turn this gigantic planet to a low-mass star, it must become about 80 to 85 times its current mass, which is equivalent to 24,000 Earth mass. But what if we decided to increase the stakes and turn Jupiter to a star like our Sun? We'll have to increase its mass up to 1,000 times what it currently is. I think we'd rather have it as it is at the moment. Regardless of its ridiculous large size and mass, this rolling Jupiter wiggles its way around the Sun pretty fast. With a rotationary velocity of 12.6 kilometers per second, Jupiter is the fastest spinning world in our solar system. That's more than 1,000 times faster than Usain Bolt when he became the world's fastest man. Isn't that amazing? In fact, Jupiter completes a full rotation of its axis every 10 hours, making it the planet with the shortest day in our solar system. This hasty rotation is the reason for Jupiter's strong magnetic fields, or magnetosphere, and ultimately contributes to the harmful radiation around the planet. Scientists reckon that the magnetic field on Jupiter is 20,000 times more than that of Earth. The magnetic field is so strong that it blows away solar winds about 3 million kilometers before it gets to the planet, and it sweeps as far as Saturn. Ironically, 1 year on Jupiter is equal to about 12 Earth years. Aside from being the largest and heaviest planet in the solar system, Jupiter also has 79 moons. Only Saturn has more with 82 satellites. Also, Jupiter is one of the 4 exclusive planets surrounded by rings. The Colossus gas giant has 4 sets of rings: the halo ring, the main ring, the Amalthea Gossamer ring, and the Thebe Gossamer ring. According to a recent discovery made by scientists, Jupiter is one of only 4 planets in the universe to have auroras that emit X-rays. Aurora is simply a natural luminescent phenomenon that glows in the sky. Within our solar system, only 4 planets are known to have auroras: They include Saturn, Uranus and Neptune, and of course Jupiter. Remarkably, the X-ray auroras on Jupiter pulsate every 27 minutes and are said to be 100 times bigger and stronger than those on Earth. To the south of Jupiter's equator is one of the most significant features called the Great Red Spot. It's basically a large anticyclonic storm that's been on the rampage for more than 200 years. It measures about 24,000 kilometres in diameter and between 12 to 14,000 kilometres in height, meaning it's large enough to swallow 3 Earths. The storm was first discovered by Giovanni Cassini in 1665, but scientists have continued to study this phenomenon ever since. At the time when Cassini discovered the Great Red Spot in the 17th century, it was believed to be about 40,000 kilometres wide. However, the Juno space probe, which recently explored the planet, suggests that the Great Red Spot is shrinking and might soon disappear within the next few decades. But until then, it remains the largest storm in our solar system. The Juno spacecraft is also one of the first space probes to enter into the planet's orbit, and it showed us things that helped us solve a lot of mysteries and misconceptions that we had about the planet. The internal areas of the planet are divided into layers. Each layer is separated from the next by a huge distance, and the climate condition ranges from one layer to another. As a gas giant, Jupiter is predominantly made up of hydrogen, helium and liquids, so it doesn't have a surface where humans and spacecraft can land. But what would happen if you found yourself inside Jupiter? Just to mention that the regular NASA spacesuit wouldn't suffice for this experiment, but assuming you had a special spacesuit and somehow you lost your mind and decided to skydive into this strange world, you'd travel through a thick atmosphere at around 180,000 kilometers per hour, 110 miles per hour. That's pretty much lightning fast compared to Felix Baumgartner's speed of 1,358 kilometers per hour, 843.6 miles per hour, when he skydived from space in 2012. Back to our extreme now. While you're still falling, you might be able to catch a glimpse of the Sun, but it wouldn't exactly make any difference. On average, the difference between the Sun and Jupiter is believed to be about 484 million miles, 778 million kilometres. And based on this pinpoint calculation, the light from the Sun will travel for 43 minutes before it arrives at Jupiter. Once you reach the ammonia clouds, which is about 250 kilometres, 156 miles deep into the planet, you will be subjected to temperatures of around minus 150 degrees Celsius, minus 240 degrees Fahrenheit. Now it's time to feel the wrath of this fast-spinning planet. You'll get tossed around like a piece of card at a speed of 482 kilometres per hour. If you miraculously survive this and manage to continue your trip further down, you'll gradually lose light until it becomes completely pitch dark. You'll get some occasional stints of brightness caused by lightning, but that's if you're lucky enough to get struck by it. If that's the case, you'll be faced with some intense level of pressure, about 1,000 times what you'd normally feel on Earth's surface. Your special suit would most likely be destroyed at this point, except it's made of low-alloy martensitic steel. The pressure and temperature will continue to rise and rise and rise until you reach the superficial ocean of hydrogen. Here, you'll experience a similar temperature of that of the Sun and pressure that is 2 million times greater than the standard pressure levels on Earth. A few miles down and you'll get trapped by a conducting substance known as metallic hydrogen. And that perhaps would be the end of your unsolicited adventure.